Okay, let's continue. Okay, I just wrote here what I did before. So this I have the second derivative of this product, the first derivative of this product, and this is plus a0v. Now, attention this minus sign over here, okay? Now, I will develop just simple, this is very, very simple analysis, okay? If I develop this second derivative, okay, that's the first derivative of this VA2 prime. It's just is the V prime A2 plus VA2 prime prime. Now, this term here, I have two terms, and this one I have plus 2. Now, this term is equal to this term. So if I add them, then I have 2, let's say, right down here, 2A2 prime V prime, okay, plus VA2 double prime. Then I add the same terms, I add these 2 times A2 prime V prime plus A2V. Okay, now develop a minus VA1 prime, just a product, okay, derivative of a product. So minus A1 V prime minus A1 prime V, okay? This is V from here, okay? I'll put a blue one there, okay, no problem. Okay, just to, this is V. Okay. Now, this is A0. Okay, this is important because now I'll compare, okay, I impose, okay, the self-adjoint, okay, using exactly, don't forget, the boundary condition, okay, U of A, U of B, the limit, okay, A and B, okay, the limit of the domain, okay, this is 0. This implies, okay, this here, okay, is a consequence. I want to impose this to be 0. So this V of A, V of B is equal to 0. So the boundary condition. So I can say that L and L star are formally self-adjoint. Okay, just to review this. Okay. Now, what I add, okay, this I have to add this just to obtain the right-hand side. Then I can write easily, okay, this term over here is the, when I add the same here, okay, I just group it here. Now I can compare, okay, LU and LV, okay, the coefficient must be the same. So look, A2 is identical to A2. Just look at here and there. Now, 2A2 prime minus A1 is equal A1. Okay? Just look at from here and there. So this implies that 2A2 prime minus 2A1 is equal to 0. Then A1 is equal A2 prime. Okay, from here. Okay, that's now from here I have A2 prime minus A1 prime plus A0 is equal to A0. Let's see, A0. Okay, this has to be A0, the same, because L is equal to L star. Okay, don't forget L star is L. Okay, is it formally self-adjoint. Okay, now see, look, this here will be also 0. Why? Because this implies, if I take the derivative of A1 prime, this is equal A2 double prime. So this is a consequence of this. So this will be 0. So A1, A0, okay, does not change A0. Okay, the same value. Now, so from this, I can write easily that L U is equal. Now you see, A2 is the same. A2, let's put U double prime. Now this term over here, okay, has to be equal to A1. Okay. Now let's write down here 2 A prime 2 minus A1. Okay, so these over here, how to change this? Okay, so this here, look, don't forget that. Okay, don't forget that this here is just A2 prime. Okay, you just look at here. Okay, A1, you see, A1 is equal A2 prime. So 2A2 prime minus A2 prime, I can write down 2A2 prime. Okay, I'll write down here. Okay, look, I'll write minus A1. Okay, now A1 is equal A2 prime. You see, from here. Okay, A1 is equal A2 prime. So the term over here will be A2 prime. Okay, so this A2 plus A2 prime U. Okay, this term over here I'll call R. Okay, plus RU. Okay, that's LU. Now this is, attention now, this is self-adjoint. Okay, formula self-adjoint. In general, you can group this term in here as D of dx. Don't forget A2, A prime, A2 prime, and R, a function of x. Okay, as I said before. So this I can write down as A2 y prime. Let's write down D of dx. Okay, D of dx of U plus RU. You see? So this is the self-adjoint operator. This is a D of dx. A2, write down A2 of x, and this D dx plus R of x. Okay, that's operator, and I like to emphasize that this operator here and there. Okay, in general, okay, in the literature, okay, instead of write A2x, it's common to substitute just a symbol. Okay, this is a P of x. This appears in the literature, and this will be P prime. See, in general. So I can write L of U, okay, is equal P U double prime plus P prime U plus R U. Okay, so this formally self-adjoint operator. Why this L star? Why this is important? Okay, you see in the next video that if I substitute V by G, okay, I already put G over here. Okay, G over here. Okay, G will be the green function. Okay, and then I use the same idea. Okay, this for the next video. Okay, this is LU. This is equal Now let's put the color here. Okay, that's same color. Okay, if I substitute G, this is G, and this LG. Okay, and this will be U. Okay, this is a self-adjoint. Okay, this is a tensional LG. Okay, and we will see that LG will be associated, related to the Dirac delta of Dirac delta. Okay, there's a symbolic function. Okay, this will be for the next video. Okay.